Dear friends, this is the lecture number 2 of motion in a straight line. In the previous lecture we discussed about distance and speed, but in this lecture we discuss about velocity and acceleration. So let's first start from velocity. So I'll tell you that velocity is just speed plus direction. Speed is a scalar quantity, you know. Speed plus direction, when direction is added in speed, then it becomes velocity. So simple, I can tell you here, speed at a particular direction. Speed at a particular direction, that is called as velocity. Speed of a body at a particular direction. Or we can tell its definition, distance covered by a body per unit time, which is nothing but definition of speed. Distance covered by a body per unit time in a particular direction. So direction is also added there. It's called velocity. Or we can tell another definition here. The displacement covered by a body in unit time is called as velocity. Or we can also tell another definition. The time rate of change of displacement is called as velocity. So velocity is a scalar or vector. So it's a vector quantity because it has direction. And what is its SI unit? That is same as speed, meter per second. CGS unit, centimeter per second. Dimensional formula same as speed, m0 L1 t to the power minus 1. So this is the complete address of velocity. So if I tell you then what is average velocity, what do you mean by average velocity? Just similar to average speed. What was the average speed formula? Total distance by total time. Similarly, average velocity is equal to total displacement divided by total time. This is the average velocity formula. Same formula is also applicable for time division and distance division. If I tell distance division formula, same velocity, average velocity, that is V2, V1, V2 by V1 plus V2. If body covers half of the distance, half of the path with V1 speed, V1 velocity, and the other half with V2 velocity, then you can find it's also the average velocity in a particular direction. And also the distance time division formula, V average is V1 plus V2 by 2. But in a particular direction, I told you. When this happens in a particular direction, then not treat that velocity, speed, both are same thing. We can use it. Average velocity, average speed, everything is same. Then come to instantaneous velocity. Same as instantaneous speed. Instantaneous velocity, instantaneous speed, both are totally same. Why? Because instantaneous means very small time. If it's very small time, then it has a particular direction. Very small distance, it has a particular direction. So very small distance is same as also very small displacement. So instantaneous velocity, if I tell you, that is also ds by dt, but you can write here vector symbol. If I tell you instantaneous velocity, same as instantaneous speed. So what you read in speed, everything also applicable in velocity. But to distinguish more about speed and velocity, I am giving one question so that you can be able to distinguish it more. Question is like this. This is a clock. This is your, suppose let's take this is your minute hand. This is your minute hand. How much length? This length is, suppose you take its length, suppose 2 meter. It's a very big clock. The length is 2 meter. So my question is, so this minute hand first, this is the position of the minute hand first I am drawing here. Okay, this is the 12, this is 6, the clock, you have the idea about the clock. So this is 3 and this is 6, this is 9. Okay. So my question is, what is, you find the average speed and average velocity. Find the average speed and average velocity. Average velocity when the clock, when the minute hand moves from A, B, C, D, I am just naming it. When minute hand moves from A to A. When minute hand moves from A to A, find the average speed and average velocity. Both you find. Second case, when it moves from A to C. Third case, when it moves from A to B. Then fourth case, when it moves from A to D. In the 4 cases, you find average speed and average velocity of the tip of the minute hand. Only of the tip of the minute hand. The minute hand length I told you 2 meters. If 2 meters is the length of the minute hand, and the average speed and average velocity of the minute hand in these 4 cases. This is a question to you to distinguish more about average speed and average velocity. So now let's come to another quantity, that is acceleration. The next quantity is acceleration. Now we'll discuss about this quantity. What do you mean by acceleration? You all have listened that in vehicles there is one accelerator, that is called accelerator. What is the function of the accelerator? When we turn the accelerator in bike, then speed increases. When we press the accelerator in cars, then also speed increases. So what do you mean by this acceleration? The device is accelerator. So the name accelerator comes from acceleration. Which do acceleration is called accelerator. Exactly what is accelerator and when it comes into action? When velocity of a body changes, acceleration comes into action. When velocity of a body changes. So what is the definition of acceleration? The rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration. Also you can tell change in velocity per unit time. Another definition also you can tell change in velocity per unit time is called acceleration, or rate of change of velocity is also called acceleration. So this acceleration formula I can write here, change in velocity per change in time, del v by del t. This is the acceleration. But I want to share you one important concept here. Velocity change. This velocity consists of 2 things. One is magnitude, that is called speed. Velocity magnitude, that is speed, and it has also one direction. Velocity change means what change? If speed change, then also velocity change. If direction change, speed remaining constant, then also velocity change. If both change, speedy direction, then also velocity change. The velocity change in all cases. And when the velocity change, acceleration comes into action. I told you 3 cases. Let's discuss the example of this. I am telling first, speed changes, either increase or decrease. Speed change, but direction is constant. Let's discuss an example in your day-to-day life where speed changes but the direction remains constant. Suppose you start a vehicle and immediately you turn the accelerator. In a particular direction, at least for some distance, in a particular direction you turn the accelerator, what happens to the speed? Increases. Speed increases. Initially, when you start, then turn accelerator, speed increase, but direction you keep constant for some distance. There also acceleration comes. Another example of that also I am telling you. One apple falls from a tree. I always will take example of apple. Take the example of a mango. Mango falls from a tree. What happened? Initial velocity when the mango falls, it's 0. But gradually when it comes down, its velocity increases. But the direction constant, it moves downward. Direction constant. But speed increases. That is also acceleration. You know that acceleration is constant, 9.8 meter per second square acceleration due to gravity. Let's discuss. This is the first example I told you where speed varies but direction constant. Second one I am telling you where speed constant but direction change. That is also acceleration. Now let's discuss one example. You think one example where speed constant but direction change. When a body moves in a circular path. When a body moves in a circular path, suppose you start your vehicle, you maintain the vehicle particular speed, suppose 20 km per hour, and you move in a particular circle. You move in a circular path. But speed is constant, that is 20 km per hour. Then what happens here? What happens here? Here, speed is constant. Speed is constant, but what about the direction? Direction is changing at every point. Here the direction is along this tangent, here the direction is along this tangent, here the direction is along this tangent, here the direction is along the tangent. Velocity direction is along the tangent, you see. At every point direction change, but speed is constant, 20 km per hour. This is called uniform circular motion. There is also acceleration. Don't think that acceleration means only speed increase or decrease. Acceleration also speed constant but direction change, that is also acceleration. Suppose you are going in your vehicle on a road. This is the road, suppose you are going in your vehicle with 20 km per hour. And now you turn your vehicle here. Suppose you turn your vehicle. You turn your vehicle on this road. But it's 20 km per hour. You have not decreased your speed. You maintain your speed 20 km per hour, but you turn your vehicle. What happened here? Velocity change or not? Yes. But speed constant. But due to change in direction, velocity change. Here is also acceleration. This is also called acceleration. And the third one I told you, speed change as well as direction change. Both change. That always happens. That always happens in our day-to-day life. When we take our vehicle on the road, we always go in varying speed but in different directions. Sometimes we have to turn to right, turn to left, turn to right, like this. This last example, this is our day-to-day life situation. This always happens. But in all cases, acceleration is there. acceleration doesn't mean only change in speed, but also change in direction means acceleration. So then who told you that there is one accelerator in a vehicle? Who told there is one accelerator in a vehicle? You now think. Actually, there are how many accelerators in a car? In a car, there are how many accelerators? Now you think. Those who are responsible for change of speed, for change of direction, they are the accelerators in a car. Not only one device which is so called as accelerator. You now make a list of the accelerators in a car. You pause the video here and make a list of the accelerators. And now I am going to write the name of the accelerators in a car. And you check whether you have written correctly or not the accelerators in a car. What are the accelerators in a car? One is the so-called accelerator. That everybody is telling it accelerator. The second one is what you have written. That is steering is also one accelerator. Because by the help of the steering we change the direction. That is also one accelerator. Third one is brake, one accelerator. Because by the help of the brake we decrease the speed. Deceleration. Brake is also one accelerator. You can also write, some students tell, sir, handbrake is also an accelerator. When the vehicle is moving, if you use the handbrake, the vehicle suddenly comes to rest. That also decreases the speed. So that handbrake also can be turned as one accelerator. So like this, we can write the many accelerators are there in a car. So who told there is only one accelerator in the car? So all these are the accelerators in the car. So now this is about the acceleration is equal to change in velocity by change in time. Change in velocity by change in time. A simple question. If I tell you to do simple question about this velocity, about this acceleration. Suppose one ball moves with velocity, suppose 20 meters per second, strikes a wall and return back with the same velocity, with the same speed. A ball moves with speed 20 km per hour, strike a wall and return back. The time of interaction del t is 0.1 second. My question is, find the acceleration here. Find the acceleration here. Let's do this question. So you try this question. You first pause the video here, do this question, and again when I am writing the answer, you check whether you have done correctly or not. Okay, so let's do this question. Acceleration is equal to change in velocity by change in time. We can do this method very easily if we use cap. I cap, J cap, K cap. We can do it very easily. You see how I am doing it very easily by the help of cap. So V1 vector. So del V means that is V2 vector minus V1 vector. Means final velocity minus initial velocity. But what is V1 vector here? V1 is 20 I cap meter per second, because it goes like this. Positive x-axis 20 I cap. V2 vector means this is minus 20 I cap meter per second. Return back. Minus 20 I cap meter per second. Then time interval is 0.1 second. Then what is the acceleration? So acceleration is equal to V2 minus V1. So V2 is how much? Minus 20 I cap minus V1 is how much? 20 I cap divided by 0.1. So it is minus 40 I cap by 0.1 So it will now become 0. So this is 0.1, 1 by 10. So it become now 400. Okay, 400 meter per second square minus I cap. Hope you got the right answer of this question. Okay, so 20 I cap, this is 20, it become minus 40, and 1 by 10, 10 go to the numerator, become 400 meter per second square minus I cap. So we got the answer with the magnitude as well as direction. Where is the direction of acceleration? Negative x-axis, and the magnitude is 400 meter per second square. Like this you can find the acceleration of a body. Another question also I can tell you, these are the fundamental questions. Suppose once you move with a speed of 20 km per hour to east, suddenly what happened? You turn your vehicle to north without changing the speed. Turn your vehicle to north without changing your vehicle, without changing your speed. Let's take it 20 km per hour, it's not possible for you. Let's take 2 meter per second. 2 meter per second, for easy calculation I say in the data. Suppose you are going 2 meter per second to east and you turn your vehicle to north, but speed is 2 meter per second. Within how much time? Let's take the time is suppose 2 seconds. Within 2 second time you change your vehicle from east to north. Change the direction of your vehicle from east to north. My question is calculate acceleration. Calculate acceleration. How will you calculate it? Let's draw the figure. You are going to east. Now you turn the vehicle to north. Okay. So this is V1. This is V2. This is V1 and this is V2. Then my question is to find acceleration, means change in velocity by change in time, means V2 minus V1 divided by del T. We can also calculate this question in terms of cap, but I am not going to do. I am going to do it by triangular law. Let's see. I am going to do in another method. You should know all the methods to do the questions. Another method I am going to do. So V1, this is V2. So you have to find V2 minus V1. V2 vector minus V1 vector we have to find out. Let's see. V2 minus V1 means you have to draw the negative of V1 first. Negative vector of V1. So V2 minus V1 means this is V2 plus minus V1. So minus V1 if you draw, I am drawing here. This is minus V1. Now V2 is added with the minus V1. Back to subtraction. V2 is added with minus V1. So which law will be applied here? Triangular law or parallelogram law. Which law will apply to add V2 and minus V1? If you are telling the answer, triangular law, you are correct. So this is the resultant. This is del V vector. A resultant. Change in velocity vector, del V vector. Okay. So now let's find that del V vector. Magnitude first. Del V vector magnitude is equal to. So the two vectors are perpendicular to each other. So V1 square plus V2 square. The rest formula minus 2 V1 V2 cos 90. It's root over. So this part is 0 cos 90 0. Only V1 square plus V2 square root over. So 2 square plus 2 square root over. So this is 2 root 2 meter per second. 2 root 2 meter per second. Change in velocity. Okay. Then what is the acceleration here? Then acceleration magnitude how we will get? We will get acceleration magnitude is equal to del V magnitude by del T. Means 2 root 2 meter per second by, I told you in 2 seconds, so 2 seconds. 2 to cancel, it is coming root 2 meter per second square. So this is the acceleration magnitude. But where is the direction of acceleration? It's very clear the direction of acceleration. In this direction you can find getting the angle from here. The direction of acceleration. Or if you write beta, okay, no problem. Beta you can also write. We can find the direction of acceleration. You see, tan beta is equal to this by this, V1 by V2. Only magnitude will take, both are 2 by 2, it becomes 1. So beta is equal to 45 degree. Means it's, this direction is what? So this is the north side and this side is west. This side is east, but this side is west. So it will be northwest. North, remember, this arrow is towards this, so this is east side. Don't write northeast. This is north, this is west side, that is towards this direction. So the direction of the acceleration is 45 degree, not required, right? You can directly write down here west north or northwest. So this is the direction of the acceleration. If any question will be asked to you, then you can easily find out the acceleration of a body by using the formula del V vector by del T vector. Then what do you mean by instantaneous acceleration? Instantaneous acceleration of a body at a particular instant less than 10 to the power minus 9 second. Same thing, del V by del T, but here we'll use the condition limit del T tends to 0, means we'll do for very small time as instantaneous. Del V converts to dV and del T converts to dt. So instantaneous acceleration is equal to derivative of velocity with respect to time, dV by dt. Also we can write this expression more, d by dt. This is ds by dt. In place of a v, I wrote its instantaneous formula. So it now becomes d square s by dt square. So this is another formula of instantaneous acceleration. D square s by dt square. You check properly where I did the mistake. Try to find out where I did the mistake. You can pause the video here and see where I did the mistake here. Are you thinking? Are you thinking that I have done the mistake here? In this case, this is d square. I left 1 2 here. So this is d square t square. If you are thinking like this, then you are wrong. Then you are wrong. No 2 is required to write there. Okay, no 2 is required to write there. Why? Because this d square by dt square, this is the symbol of a double derivative. Derivative symbol is d by dt, but double derivative symbol is d square by dt square. This is the symbol of a double derivative. Okay, so no mistake I have done here. Remember, double derivative means displacement derivative is done twice. When first the derivative is done, we got velocity. When again the derivative is done, we got acceleration. So I can conclude the statement here. Acceleration is double derivative of displacement. Acceleration is double derivative of displacement. To get acceleration, we have to differentiate displacement twice. Try to remember this formula. This is a very important concept. So if you do one question, then also you will be more clear about this. Let's do one question. Suppose x is equal to 3t square plus 40 plus 5 plus 40. Let's increase one variable. 3t cube, 4t2 square, 5t plus 9. X is this much. This is meter. Find the acceleration. Find the acceleration of body at t is equal to 2 seconds. Find the acceleration at t is equal to 2 seconds. Acceleration you find. Just before I told you, if displacement of distance is given, you can find acceleration doing the derivative twice. Twice you have to do derivative. First, if you do the derivative, you will get speed. Dx by dt, you will get speed first. Dx by dt. So what is this? If you do derivative of this, so 9t square plus 8t plus 5, its constant derivative is 0. This is the derivative done first once. Then to get acceleration, again you have to do derivative, dv by dt. So this is 18t plus 8. So this is the instantaneous acceleration. But if the question is asked to find at a particular time, suppose 2 seconds, find the acceleration when t is equal to 2 seconds, you have to put here. So 18 into 2 plus 8. Then you will find its acceleration. Okay, so this is 36 plus 8. So now you got it 44 meter per second square. The acceleration of the body. So this is the instantaneous acceleration, how we calculate doing the differentiation twice. Then come to the nature of motion. These are the quantities we discussed now today. Let's come to what are the nature of motion. First is uniform motion. What do you mean by this? Uniform motion. Uniform motion means body moves with constant velocity. It covers equal displacement in equal intervals of time. Discipline motion, uniform motion. Velocity is constant. Constant in both direction as well as a magnitude. As well as a magnitude. That is called uniform motion. Remember, in this motion, velocity is constant, magnitude should be constant, direction also should be constant. Both has to be constant, then that is called uniform motion. Equal displacement covered in equal interval of time. Is there such example of uniform motion in our day-to-day life? You think about it. Think about it. You can pause the video here and think what are the examples exist in our day-to-day life about uniform motion. Very difficult to maintain. Okay. Now I am telling you such example is raindrop falling. Falling of a raindrop is the example of uniform motion. When the raindrop falls, it falls with a constant speed in a downward direction. Remember, the speed of a raindrop never increases. Raindrop speed is constant. Raindrop falling is not a free fall. Remember, that is not free fall. It falls with a constant speed in a particular direction. That is the best example of uniform motion when velocity constant. Then come to non-uniform motion. If non-uniform, then I can tell you velocity not constant, just opposite to it. Either speed varies or time varies. If either speed vary or time vary, then the motion become accelerated. I can tell also non-uniform motion. Also I can tell it as accelerated motion. This is also can be called as accelerated motion. Acceleration happens. Then I can classify another this oscillated motion into two types. One is uniform oscillation. Uniform oscillation means what happens? Velocity changes equally in equal intervals of time. I told you velocity changes equally in equal intervals of time. That is uniform acceleration. Here acceleration is constant. Acceleration is constant. Constant means acceleration will be a number. No time variable will be in the expression of acceleration. If I tell acceleration is simple 2, if I tell acceleration is 2t plus 5, here acceleration varies because time is here. With time acceleration changes, it varies. But here acceleration constant. Constant and varies and variable means you will understand like this. Where there is no t means it is constant. So uniform acceleration means acceleration is constant. So this is the uniform acceleration. Then the question is coming to your mind, which motion in our day-to-day life is uniform acceleration? Think about it. Pause the video here and think about it. And again you play the video and listen my answer. Uniform acceleration is freely falling body. That acceleration is constant, 9.8 meter per second square. One mango falls from a tree, something falls from my hand. This is uniform acceleration. Here acceleration is constant, 9.8 meter per second square. Then non-uniform acceleration means what happens here? Means acceleration is not constant, that is non-uniform acceleration. Practical example of non-uniform acceleration. Acceleration not constant. When you drive your vehicle on the road, sometimes you increase the acceleration, sometimes again you decrease the speed. Sometimes you increase the speed, sometimes decrease the speed. Sometimes you change the direction to right, sometimes to left. That is the best example of non-uniform acceleration. So these are the different nature of motion. But again we will understand this more clearly if I will write one question for you. So let's discuss one question here. X is equal to 3t square plus 4t plus 6. Find the nature of the motion. Question is find nature of motion. What is the nature of motion? Okay. So what is the nature of motion? How I know? We will find its velocity. Okay. First let's find its velocity. Dx by dt. What is the velocity now here? Do the derivative once. 60 plus 4. Is the velocity constant? No. Because time is here. Time is here, velocity is not constant, so it's not uniform motion. Not uniform motion. Then find acceleration. Acceleration. dv by dt. What do you get? 6. Is the acceleration constant? Yes. The acceleration is constant now. If the acceleration is, how I know it's constant? Because no time factor is here. Acceleration is 6, always 6, so it's constant. So I can tell now the body is in uniform acceleration. The body is in uniform acceleration. This is the nature of motion. Okay, I am now giving you one question to you here. That 4 bodies, let's take 3 bodies, A, B, C. I am writing their equations and you will find their nature of motion. XA, A position varies with time like this, 3t cube plus 2t square plus 6t plus 7. B body position varies with 2t plus 9 and C body position varies with 3t square plus 2t plus 6. You have to find their nature of motion. Then when you will find their nature of motion, from that also you will get a trick to know. Just looking at this equation, you can able to tell within 1 second the nature of motion. If you will find its answer, then you can able to know it. So today we discussed about velocity and acceleration. Thank you.